Here is the graph of the function y equals x plus 3. And the reason it is a function is because if you choose any x value, it will only ever be linked to one y value. Here the x value 2 is linked only to the y value 5. And if we choose another x value, say minus 1, it will again be linked to only one y value, in this case 2. And if we choose the x value minus 4, it is clearly linked to only one y value, in this case minus 1. This will be true for all points on the line. In words, we can say that a function links every x value to only one y value. They often refer to the x values as the input values or the domain. And the y values are called the output values or the range. So a function links each element in the domain to only one element in the range. This parabola is also a function. Again, the reason is because each x value is linked only to one y value. For example, x equals minus 2 is linked to only y equals 5. And x equals 1 is linked only to y equals 2. And x equals 2 is linked only to y equals 5. In other words, each element in the domain is linked only to one element in the range. This parabola lying on its side is not a function. And the reason is, if we take any x value in the domain, say x equals 9, it is clear from the graph that it is linked to two y values. In this case, the values are 3 and minus 3. To quickly check whether a graph represents a function or not, we can use what is called the vertical line test. To do this, we can use a vertical ruler and move it across the graph from left to right. If the ruler at any time cuts the graph more than once, then we can immediately say that it is not a function. The ruler clearly cuts the parabola on its side more than once. This is why it is not a function. The other two graphs are functions, because they both pass the vertical line test. The straight line is in fact a one-to-one function, and the parabola is a many-to-one function. In other words, we have two different types of functions here. To test for which type of function we have, we use what is called the horizontal line test. To do this, we can use a horizontal ruler and move it across the graph from top to bottom. If it cuts the graph only once, then the function is a one-to-one function. And if it cuts more than once, then it is a many-to-one function. Here the ruler clearly cuts the graph at two places. And also, in a one-to-one function, each x value is linked to only one y value. And in a many-to-one function, each x value is again linked to only one y value. But in this type of function, we have more than one x value linked to the same y value. In other words, we have many x values linked to the same y value. And also note, in mathematics we usually give a function a name. For example, f of x, or g of x, or just f and g. Please pause the lesson if you need more time to look at all of this. Let's do a few examples together. We are given the exponential graph y equals 2 to the power of x. Is it a function? To check, let's use the vertical line test. Moving the ruler across the graph from left to right, it will only ever cut the graph once. So yes, it is a function. Next we are asked what type of function it is. To answer this, we need to use the horizontal line test. Moving the ruler from top to bottom, it will only ever cut the graph once. This means that it is a one-to-one function. Please pause the lesson if you need to. Next we are given the graph of a circle. Is it a function? To check, let's again use the vertical line test. Moving the ruler across the graph, it will clearly cut the graph more than once. The circle is therefore not a function. In the next example, we are given a graph made up of 5 separate points. Is this a function? If we use the vertical line test, it is clear that the ruler will only ever go through one point at a time. So yes, it is a function. But what type of function is it? If we use the horizontal line test, it is clear that the ruler passes through all the points at the same time. This is therefore a many-to-one function. Please pause the lesson if you need to. In the next example, we are given a graph with a break in it. Is it a function? If we use the vertical line test, it is clear that the ruler will only ever cut the graph once. So yes, it is a function. But what type of function is it? If we move a horizontal ruler across the graph from top to bottom, it will only ever cut the graph once. Please note, the empty circle tells us that the point is not included on the graph. This is therefore a one-to-one